You light a match, and suddenly there's fire. Bright, hot, alive-looking. It dances, it crackles. It destroys whatever it touches. You think you know what fire is, because you've seen it your whole life. But here's the paradox. Fire isn't a thing at all. You can't hold it. You can't bottle it. And even stranger, nothing that burns is actually full of fire before it ignites. So what suddenly appears when a flame starts? And here's something that should really bother you. A massive tree, hundreds of kilograms of solid wood, has not come from the soil. If you carefully weigh the dirt before and after a tree grows, almost all the soil is still there. So where did the tree come from? The answer to that question and the answer to what fire really is turn out to be the same. And once you see it, your everyday idea of burning never recovers. Subscribe and like for more videos that explain what's really happening beneath the surface, because fire is not what your intuition tells you it is. Let's start with the obvious picture. You're taught that fire is something that consumes fuel. Wood burns, paper burns, gasoline burns. Fire is hot, so it must be releasing heat stored inside the material. That sounds reasonable, but it's wrong in a very deep way. Take a piece of wood. Why doesn't it just burst into flames sitting on your table? It's surrounded by air. Oxygen is everywhere. If burning were just about mixing wood with oxygen, your house would be a permanent inferno. Clearly something is missing. The missing ingredient is energy, not fuel, not oxygen, but a trigger. Fire needs a push to get started. That already tells you something important. Burning is not a passive property of matter. It's a process. A very specific one. Here's the key idea Feynman loved to emphasize. Fire is chemistry happening fast. Violently fast. But chemistry follows the same rules, whether it's slow or explosive. Inside wood are atoms, mostly carbon, hydrogen, and oxygen, arranged in complex molecular structures. Those atoms are held together by electrical forces. And electrical forces, as Feynman liked to point out, are unimaginably strong. Stronger than gravity by a factor so large, your brain refuses to picture it. When wood burns, nothing mystical is happening. Atoms are rearranging. Carbon atoms are combining with oxygen atoms from the air to form carbon dioxide. Hydrogen atoms combine with oxygen to form water vapor. That's it. No substance called fire is being released. So why the flames? Why the heat? Because those new arrangements, the molecules after burning, are more stable. The atoms are happier there, energetically speaking. And the excess energy has to go somewhere. It comes out as heat and light. Fire is not destruction. It's reorganization. Now let's return to that tree. Where does its mass come from? Not the soil. Almost all of it comes from the air. Carbon dioxide, a gas so thin you can't feel it, enters the leaves. Sunlight provides energy. And using that energy, the tree tears carbon dioxide apart and builds complex molecules, wood, fibers, sugars. The tree is literally made of solidified air, assembled using sunlight. This is where fire and life connect. When you burn wood, you are reversing what the tree did. You're taking those carefully assembled carbon structures and letting them fall back into their lower energy state. The sunlight that was stored in chemical bonds is released again as heat and light. Fire is frozen sunlight being paid back with interest. And now comes the part that really messes with your intuition. You are doing the same thing. You are a slow fire. When you eat food, you are not gaining energy in some abstract sense. You are taking in molecules rich in carbon and hydrogen built by plants using sunlight and reacting them with oxygen. But instead of letting it happen all at once, like a flame, your body does it step by step, carefully, controlled. The energy is released slowly enough to build muscles. Power neurons maintain temperature. If that same chemistry happened all at once, you wouldn't be alive. You'd be on fire. So why doesn't your body burst into flames? For the same reason wood doesn't. Activation energy. Chemistry has barriers. Nature doesn't roll downhill instantly unless it's given a push. Flames are what happen when you remove the barriers all at once. This is where common sense fails. We imagine fire as something aggressive that attacks matter. But fire doesn't force atoms to do anything unnatural. It allows them to do what they were already inclined to do, given the chance. And the chance comes from temperature. Heat is not a substance either. It's motion. Atoms vibrating, colliding, jostling. When you heat something, you're shaking its atoms harder. Shake them hard enough, and some molecular bonds break. Once a few break, the reactions release more energy, which breaks more bonds, which releases more energy. That's a chain reaction. Fire is a runaway feedback loop. This also explains why fire needs oxygen. Oxygen is unusually good at forming strong bonds. When oxygen atoms latch onto carbon or hydrogen, they release a lot of energy. That makes oxygen the perfect partner for combustion. Without it, fire dies not because fuel disappears, but because there's no energetic downhill path left. Now let's talk about the flames themselves. Why are they yellow? Why do they flicker? The yellow glow doesn't come from fire as such. It comes from tiny, hot particles soot glowing as they're heated. In a very clean flame, like a well-adjusted gas burner, the flame is blue because there's little soot and most of the light comes from excited molecules relaxing back down. Again, no fire substance, just atoms, energy, and probability. And probability matters. Fire doesn't burn uniformly. It dances because molecules collide randomly. Some reactions happen here, some there. Turbulence, heat flow, diffusion, all statistical processes. Fire is chaos guided by physical law. Feynman would insist on this point. Nature doesn't plan. It doesn't intend to burn. It just follows rules, and when conditions line up, fire appears as an emergent pattern. So why does this matter? Because once you understand fire, you stop seeing it as an exception. It's not special. It's chemistry plus energy plus time. The same principles govern stars, engines, metabolism, and the slow decay of everything you know. The sun itself is not burning in the usual sense. It's doing something even stranger, but the light it sends down is what powers nearly every flame on Earth, directly or indirectly. Fire is part of a cosmic energy loop that began long before Earth existed. And here is the philosophical takeaway Feynman would leave you with. Fire feels fundamental because it has dramatic. But drama is not depth. The real story is always smaller, quieter, more precise. Atoms rearranging, energy flowing, probabilities adding up. Fire doesn't exist as a thing. It exists as an event. And once you see that, the world changes. Burning wood, glowing stars, living bodies, they're all variations on the same theme. Energy moving from less stable arrangements to more stable ones, leaving light and warmth behind as a kind of cosmic signature. That's what fire really is. Not destruction. Not a substance. Just nature doing what it always does, when given the opportunity. And the fact that it looks so alive is just a reminder that reality is far stranger and far more beautiful than the stories we tell ourselves to make it feel simple.